Are we on? 1, 2, mic test. All right, good afternoon, good evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. This is going to be a very, very interesting lesson. I'm very excited, but even as we start, I am requesting that you subscribe to the channel, leave a like, share the video to other people so that they may get the same benefit you are getting. All right, and leave a comment on what you would like me to do in my next videos. All right, this is a very interesting lesson. Let's do it. All right, so in this lesson we look at complex integration. Complex integration, and the following series in this lesson will focus on 3 or maybe 2, let me just do 2 categories of complex integration. The first one that we'll do is line integration. Then secondly, we're going to do contour integration. All right, so these are the things that we're going to do, and shout out to my students, students I tutor. I want you to pay attention to this because it will be very helpful. So I think the best way to start this lesson is by an example, I think, because we are already acquainted with integration, all right, how to integrate on lines. We've done line integrals, all right. So we have a function here that we're integrating, which is this function right here, okay, and with respect to z, and we have from 0 to 2 plus I. All right, sometimes this can be written as integral from 0, 0. Remember, this is 2, 1 of z by then dz like that. Okay, this can be written like this. This is 2, which is x, and I, which is the imaginary part. The corresponding coefficient is 1, like that. So this can sometimes be written like that. So be aware. So our goal in complex integration or line integrals, we just need to have one variable. Remember, z has 2 variables, x and y. It is 2-dimensional. Excuse me. Remember, z is 2-dimensional. So we need to make sure that in the given integral, we only have one variable. We can choose either to have only an x variable, okay? We have x variable, meaning that our coordinates that we're going to use or as our limits of integration will be these that are in x. If we choose to have y variable, we will have y everywhere here, meaning that this will no longer be dz, it will have to be dy, and the limits will be these in y, and we are done. Then from there, it's just integration. All right, so we pick a line that we choose. So we've been given to integrate along this line, y is equals to x squared. So first of all, we need to find an expression for z using this equation that you are familiar with. So this will be your friend throughout line integration. You will use this equation to find your dz corresponding to whatever is there, and you simply integrate like that. So according to our line here, y is equals to x squared, you can use any of the following equation. You can make x the subject of the formula and replace here, or y the subject of the formula and replace here. So for us, when we replace y, where there is y, we replace this x squared, because y is equals to x squared, we're going to have plus I x squared like that. Okay, meaning that our dz, the x, will be equals to 1 plus I 2x like that, meaning that our dz is now equal to 1 plus I 2x dx. Just move it here. X dx. That is to say, wherever there is dz in our given integral, we can replace with this. Okay, and we need to have y and x. We know that z bar is equal to x minus iy in this case. Okay, meaning that our integral now becomes, since we've chosen to go with x, so we're using x limits, so we are moving from 0 to 2. Then we have x minus iy. Okay, then our dz is this. Dz now becomes 1 plus I 2x dx. Okay, now we need to replace this with the corresponding value of y, which is y is equals to x squared. Like that, we replace our, remember y here, remember from our line here, y is equals to x squared. So we replace right here, okay, and we get that. So now we can distribute, so not forgetting this is from 0 to 2, we can distribute this. We are going to have x times 1, that would be, this is from 0 to 2, this is x. Okay, having done that real quickly, we have x times 1, we have x times this, we get this, negative ix squared times 1, we get negative ix squared, negative I times negative ix squared times I2x. First of all, negative I times I squared, that will be positive. Then 2x times x to the power 2, that is 2x to the power 3. Then from here, it is just simple integration that you know. So let's see, this is from 0 to 2. And we have our x. Let me just simplify, because we see that these can actually simplify. That is leaving us with plus I x squared plus 2x to the power 3 with respect to x. And this from 0 to 2. Okay, we can now start integrating this into this. So we can start integrating. This would be x squared over 2 plus I x to the power 3 over 3 right, plus 2 over 4 x to the power 4. Okay, then from 0 to 2. Then from here, we just replace upper limit first, then the lower limit later. So we're going to have 2 to the power 2 over 2 plus I 2 to the power 3 over 2. Over 3 over 3 plus this simplifies to half. Then 2 to the power 4. Minus, we see that when we replace zeros here, it would just be 0 as our lower limit. Alright, so simplifying that on your calculator, so that will simplify to that, and that will be our final answer right here. So you see how easy it is for us to integrate. It's just remembering key things. We need to make sure that we have one variable, okay? One variable that we're dealing with. We're dealing with one variable. You choose, you either go with x or you go with y, but you do that. Then from here, we have along the line, the second part. I'll allow you to do this one, and you can send me an email to show me how you have done the question. All right, so but along the line, this is from z equals to 0, which is just the coordinates 0, 0 to z equals to 2, okay, meaning our real part is 2 and our imaginary part is 0, okay. Okay, so you can find the equation of this line, okay, you can find the equation of this line, and you do the same thing that we are doing, all right. So I'm sure the equation of this line is x equals to 2. This is the equation of this line, I'm sure. Okay, this is the line x is equal to 2. All right, so confirm with me if that is the equation of the line. So after you find the equation of this line, you follow the same procedure. You use this to come up with dz. You replace in that, come up with dz, whatever, with respect to whatever variable you're going to remain with in there. Then you can finish from there. So this is how you approach line integrals. See you in the next video.